In the last video, I finished up some of the power on self-test routines that could automatically test my RAM and my VIA and my math coprocessor when the system comes up, along with the interrupt controller. And I'm not doing any tests for the PPIs currently. I did get in the new C version of the PPIs, so I have the 82C55s now in here, which are the CMOS versions. The whole system as it's sitting right now, I'm at about 0.7 amps or 700 milliamps prior to some minor changes I just made, which I'm going to talk about here. But at this point, with those quick power on self tests, I can play with things. I can change some configuration, for example, clock speed, or whether I'm going to run the math coprocessor at the full internal clock, which really means 2/3, or if I run it at half that speed internally, or other changes I want to play around with timing and things like that. And it allows me just to come up here, hit reset, and then watch both on my output on the computer to see if things log correctly, and down here if all the power on self-tests pass. And you can see on the screen, it looks like it's working fine, of course. And down here, this is post complete, everything passed. I know you can't read that, but it would be a white screen with black text if something had failed. And at this point, I can type on the keyboard, and that's working up here. I can hit escape to clear it. I can press F1 to pull up my temperature and my time, and I can keep refreshing that, and you can see that's pulling just fine. I can continue to type down below. All this functionality is working, but what's interesting is from my last video, I sped up my processor from 6 megahertz to 8 megahertz. And so I'm now running 8 megahertz on the processor, and you're going to notice two things if you've been following my videos. One is I've pulled the hat off the processor, and really it's not serving any particular purpose because I've disabled it. It's running so fast that these LEDs just don't serve a purpose. So if anything, it's adding some unnecessary load or noise on that internal bus, which I thought, well, let's just take it off. Great for when I'm doing slower speeds and I want to debug, especially when I first fire up and start building out a circuit. This is really handy. But now that I have things pretty much running and I'm now all doing all my work in assembly, that's just really not necessary. The other thing I thought about is on my external bus, I have resistors down here that I use as pull-up resistors. And these resistors right now are a 1K pull-up, and that's on pretty much anything on this bus. So the address and the data for the external bus are being pulled up to 1K. I didn't have any such resistors on the internal bus. And as I was doing my speed testing and watching my post screen and trying different cans here with different speeds, I noticed the first thing that was failing, the weakest part of this whole system, is something with my communication with the math coprocessor. Well, the thing that's quite different there is that's just on this internal bus, and I have some different things on the internal bus. I have my data transceivers up here. I have the math coprocessor. Anything else I have internally, I'd have to pull up the schematic, but there's some things that just basically tapped into that, and there are no transceivers or anything that's really helping power that. It's pulling straight from the processor. Whereas everything on this bus over here is coming out of these data transceivers or address latches. So I thought, why don't I add some pull-ups also to the internal data bus, because the math coprocessor is using the full 16 bits of the data bus. It's really not using much for addressing maybe a couple of lines, but really the biggest thing is the data bus. So you can see my lovely work here with this nice little breadboard sitting here, but basically I tapped in on the inside of the data transceivers, and I just brought those 16 data lines to the breadboard. I have a 3.3K SIP on each of these 8, and those are going to high. So I'm doing a 3.3K pull-up, and with that now I am getting 8 megahertz. It seems like pretty effectively coming out here. I probably have other things I can look at and change. Maybe I need to come back and revisit some of these resistors on the clock lines. There's probably other things, these 1Ks down here, I could potentially look at different sizes or resistance. If this is a 3.3K, this is a 1K. I did try 1K here, and it seemed to work well, but not as well as the 3.3K. I did also go lower than 1K, and that did not work well, so that was just too aggressive. But if I had something in between a 1K and a 3.3K, that's probably where I should be, but I don't have any in-between SIPs that are of this size. This physical size, basically a 9-pin. So that's what I'm doing right now, 3.3K pull-up, and down here a 1K pull-up. And probably when I get some more time, I'll do some experimenting down here with these 1Ks and see if there's other values that work better. But at this point, it seems like as I'm going through this, it's doing its RAM testing and it's consistently passing. One test is usually I need to power off the system completely and then fire it back up and see if I get different results. So I'm going to reset my Nano, and then I'm going to go ahead and turn the system on, and we'll see if everything passes on a cold start like that. And it is passing. I'm not sure if you can hear the speaker, but it's a higher pitch now, of course, because I'm running a higher frequency. Maybe at some point I'll get that on a timer. I could actually use the real-time clock, has an output clock that would stay consistent, I believe, because it's running off an internal crystal. So I could change my speaker here to run off of maybe something on that real-time clock, actually. I'm not going to mess with that, but that's something I could do if I wanted a consistent sound, or I could use, I suppose, some sort of a timer interrupt to drive that. But at this point, I think I'm going to leave the hat off. I'm going to see if I can run it at 8 megahertz and how things go. The processor isn't warm. It's slightly warmer than room temperature, but you can barely notice anything. Math coprocessor is cold. Everything else is just cold here. So I think I'm sitting pretty good with this. So I might have to figure out how to more permanently place these pull-ups in here, and I think I could probably put SIPs right down here, pull up the 9th pin on this, solder it, and run it into power. So maybe I'll try to do that next here. Okay, at this point I have removed the little breadboard that was tapping into the internal data bus. I have the SIPs right down there. I've bent up one pin, the pin that would normally go to ground or power, and I've pulled those over to VCC. So I'm going to go ahead and flip it on and test it and just see if it makes it through the test or not. And it did. And I'm going to go ahead and do a reset just to make sure I wasn't lucky once. Okay, that appears to be working fine. And again, over here, just to test, I can type, I can clear, I can bring up and refresh my time as we go. And everything looks like it's logging correctly on my Nano output. So far, so good. I'm going to go ahead and keep testing at that. But again, we've got 32 megahertz, 16 coming in to the system. So I'm running 8 at the processor. And really, I removed the hat and added a 3.3K pull-up to my internal data bus.